In this project, I evaluated the use of micro-electro-mechanical-system sensor in detecting and monitoring motor developmental delays in children with autism spectrum disorder, and this is an exploratory study. Now, because there has been documented evidence of neuromuscular disorder in a subset of patients that are affected with syndromic ASD, it is necessary to have a diagnostic tool that will aid in early diagnosis and early detection of motor delays in children with autism. The use of machine learning and Internet of Things is an area under research and exploration to see if we can actually have devices that collect motion data of patients and analyzes this data to give a report or to classify the clients in a category based on their motion. So the activities that were carried out were jumping on one leg, jumping on both legs, stacking small blocks, and coloring tiny dots. Each activity took 60 seconds at a time over several days. I used Uniqlo GUI to export the data for further analysis. For the exploratory analysis, I removed every acceleration due to gravity from each data point and resampled the data to 1 second data point because of the high sampling rate. Applied digital signal processing to eliminate noise and irregularities. I used the low pass filter. Then I had different statistical models to test if I can accurately classify the data based on or classify the subjects based on the acceleration and the angular rate of their motion. With logistic regression, my log loss was 0.68, which is very bad, and so logistic regression is not considered as a tool for further analysis. Then I tried to use linear regression. With linear regression, I used the ordinary least squared, and I had a better log loss, but it's still a bad log loss of 0.45. I tried using the Bayesian classifier and random forest. Both had very close log loss, 0.03 and 0.07 respectively, or approximately. And it is relatively good, but we want our log loss to be as close to 0 as possible, because a perfect model has a log loss of 0. Then I tried building a neural network to use machine learning. I used different hyperparameters and came up with a model with a log loss of 0.057 or approximately 0.06, which ranks second after the Bayesian classifier in the classification. And comparing the log loss of the different models I tried, using the Bayes decision tree is the best model. Log loss of the Bayes decision tree is acceptable for first trial, and when I applied a 5-fold split, I had an accuracy score of 90%, which is very promising to continue of further experiments in this area. So because of this promising results and high accuracy score in the classification of this model, more sample size and more subjects will be needed to come to a definite conclusion on the use of motion sensors in convenient ways, and that will lead to discoveries that are difficult to evaluate by humans. And there are other classifiers as it relates to the types of activities and the category of motor with delays can also be created further from the collected data.